Hi everyone, this is Dr. GVR Seshagiri, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So in this session, I want to explain about Cotter joints in definitions and terminology. So what are the important terms related to Cotter joints? We will see in this session. So first of all, what do you mean by Cotter? So in Cotter joints, so the important thing is Cotter and then types of joints and what are the various components of Cotter joint. So we will discuss. First of all, we're going to enter in this definitions and terminology. We have to discuss about temporary joints and permanent type joints. So joints are classified into two types. One is permanent type joints and second one is temporary type joints. Already we have discussed in a previous session about these two joints. So whereas in permanent type joints, two members are joined or connected with the help of permanent material like welding and soldering, gluing, riveting. These all are examples for permanent type joints. So coming to the temporary joints, so Cotter joints, knuckle joints, and couplings, these are permanent temporary type of joints. So it means, so whenever you want to remove the or replace the damaged component or you want to separate the joint, so you can easily separate them in case of temporary joints. So example, bolt and nut and coupling. So these all are you can dismantle very easily. But whereas in permanent type, not like that. So you want to replace or you want to repair the component or any member. So entire joint you have to destroy. So that some examples for permanent type is the welding type, welded joints. So now these Cotter joints are comes under temporary type joints. So in this, a Cotter is a wedge shaped piece. So it may be a rectangular cross section, and its width is tapered, either one on side or both sides taper having from one end to the another end. So why? Because it is this taper is for easy adjustment and easy removal of easy separate the joint. So sometimes the taper varies from 1 in 48 to 1 in 24. This is the standard taper size. The Cotter is a flat wedge shaped piece of rectangular cross section. So you can, so I will show you a diagram also. The Cotter, pin, ఒక 3D diagram. So this is taper varies from 1 in 48 or 1 in 24. So actually it is a rectangular piece. So generally the material is made of mild steel or wrought iron. And also the Cotter joints are classified into various types. One is socket and spigot Cotter joint. And second one is sleeve and Cotter joint. And third one is gib and Cotter joint. So one by one we will see the socket and spigot cotter joint construction details, and sleeve and cotter joint construction details, and gib and cotter joint details we will discuss. See, in this diagram, in this slide, shown socket and spigot cotter joint. So in this, the cotter joint, the important components are, one is cotter and socket rod and a spigot. So in this shown, one is the spigot and another one is socket. So here shown socket and spigot. So here in a socket and spigot cotter joint, one end of the rods, that is say A shown in diagram, is provided with a socket type of end as shown in a figure. So other end is, say B is inserted into a socket. So this rod inserted in this socket. So the end of the rod which goes into a socket is also called as spigot. So actually the cotter joint is used to join the coaxial rods. Two coaxial rods you can join with the help of this cotter. So one is socket and another one is spigot. So the end of the rod which goes into a socket is also called as spigot. The end of the rod, this one is spigot. This rod inserted into this socket. And rectangular hole is made in the socket and spigot to accommodate the cotter. So that a cotter is then driven tightly through a hole. So in order to make the temporary connection between these two rods, this is a temporary connection only. Suppose you want to separate this joint, so you can remove this cotter. So like this you can separate them. Shown in this diagram, the cotter dimensions are B width and the length or height of the cotter, and thickness of the cotter shown in this side view. So generally this type of joint is used for coaxial rods. See in this shown all dimensions related to the spigot and socket rods. The spigot rods diameter and collar, socket collar outer diameter and cotter dimensions, and then socket diameter and inner diameter of the socket, and then clearance. Some clearance between clearance is there in between cotter and this socket rods. So all these dimensions have to design as per standard empirical relations. The second one is sleeve and cotter joint. In sleeve and cotter joint, another type of cotter joint. So sometimes it is used to connect two round rods or round bars. So round type bars. So you can connect a joint with the help of this cotter and sleeve. In this type of joint, a sleeve or muff is used over the two rods and then 2 cotters. Here 2 cotters are used, and 2 muffs are sleeve. Already we have discussed in couplings, sleeve type of coupling or muff. It is nothing but cover, a rubber bush on over the 2 rods. So these are one on each rod end are inserted in the holes provided for them. The cotter joint rectangular hole is provided to accommodate the cotters. The taper of the cotter is usually 1 in 24. So sometimes the taper side, the sides of the 2 cotters are one face of the cotter. So the all construction details shown in this figure. Overall length L is equal to 8 times of the D. So in this, the main parts are sleeve, and then sleeve or muff, and then 2 cotters and 2 coaxial rods. And the important thing is taper is 1 in 24. So what is the need of clearance? 3 mm shown in this diagram. So the clearance is used to when the cotters are driven in the 2 rods, sometimes come closer to each other. One rod to another rod come closer. Thus, what will happen? The making the joint tight. So that how to provide some clearance between these 2 cotters and socket and the spigot. The socket, 2 sockets. So if you are not provided any clearance between this, there is no adjustment. So whenever these 2 rods are come closer to each other, then it will fail. So that always provide clearance between them. So another type, the third type joint is kib and cotter joint. Here additionally a gib used for supporting to the cotter. The extra part here introduced, so that in this type joint is called as gib and cotter joint. The gib dimensions separately have to take, and cotter, single cotter used in this joint. This one also used for coaxial rods. Other types of cotters are cotter without gib, shown in this diagram. There is no gib. Cotter with 1 gib, and a cotter with 2 gibs. So here shown in this diagram, gib 1 and gib 2, and 2 rods, rod 1 and rod 2, and cotter. Next type of joint is knuckle joint. So generally this knuckle joint is used to connect 2 rods which are under the action of tensile loads. Suppose 2 rods under action of one rod, another rod, the joint, the alpha for knuckle joint, axial load. So the rods may be support a compressive load, So knuckle joint may be very useful for disconnecting purpose, for adjustment or repairs. You can very easily dismantle whenever you want to repair the components, or you want to replace the any damaged part. You can do very easily. So this joint also comes under temporary type joints. So example for knuckle joints, this is our cycle chain and tie rod joint for rope stress. And in case of automobile engines, eccentric rod, valve rod joint, pump rod joint. In bridge structure, tension link in bridge structure, lever and rod connections for various types of applications are there. Knuckle joint. So I will show you the diagram. So in knuckle joint, the important components are: one is one eye end having a diameter, outer diameter and inner diameter, and then some thickness. Similarly, two end are fork end. The two eye end are also called as, two eye end is called as fork end. Here in this type rod having two eye shaped ends having outer diameter and inner diameter. All dimensions already we have discussed in design of knuckle joint. And here other part is knuckle pin. Knuckle pin is inserted into this two eye end rod or fork end. After that, insert a taper pin. Taper pin shown in this diagram, and the collar also there. The collar having thickness and outer dia and inner dia, just like the washer. So these are the important components, important parts of a knuckle joint. So the taper pin dimensions you have to calculate as per the design procedure. Similarly, you have to calculate eye end dimensions, and two eye shaped end or fork end dimensions also you have to calculate as per design procedures. After that, you have to apply checking for crushing stress, checking for shear stress, checking for tensile. So after the checking, you can say this joint is safe. Your design is safe or not. You should know. Next topic is keys. So what do you mean by key? Key is a piece of mild steel inserted between the shaft and hub. So it prevents the relative motion between the shaft and hub. Shaft having key is the key portion. Shaft. So it is inserted between the shaft and hub portion. So nothing but like this. So this is, we can say, keyway. The keyway is, it is a races to accommodate the key. So again, the keys are classified into different types. One is Sankey keys and saddle keys and tangent keys, round keys and splines. Again, these Sankey keys are classified into various types. Rectangular keys, square, like that, etc. Saddle keys and tangent keys and spline, round keys. These are the types of keys. Now, we'll see sunk keys. So the sunk keys are provided half in the keyway and remaining half in the shaft or hub of the boss of the pulley. So it is provided half in the keyway of the shaft. So shown in this diagram. Remaining half in the keyway of the hub, also called as boss of the pulley. These type of keys are called as sunk keys. So again classified into according to their cross section. The rectangular sunk key. So rectangular sunk key shown in this figure. So taper having 1:100 width and thickness shown in this diagram. So how do you calculate the width and thickness? The standard empirical relation is width W or B d by 4 and thickness is d by 6. So what is d here? D is the shaft diameter. So diameter of the shaft or diameter of the wall in the hub. Key weight, the key has taper 1 in 100 on the top side. So here shown the taper. So these type of keys are called sunk keys. And another cross section is square sunk key. So only difference is cross section. The previous one is the shape of the key is rectangular and here the shape of the key is square. So dimensions are different. In this case, the W and thickness, the width and thickness are d by 4. Same, equal. But in case of rectangular, different. One is width is d by 4 and thickness is d by 6. Similarly, parallel sunk keys. So it may be rectangular or square section. Uniform width and thickness throughout. So it may be noted that the parallel key is taperless key and is used where the pulley or gear or other mating piece is required to slide along the shaft. So it means, so whenever required, the mating piece is required, the mating piece also required to slide along the shaft. So sometimes the shaft is rotated and in rotational motion and another component, the mating piece is in the stationary. But sometimes both are required. So in that case, this type of parallel key is useful. Gibbet key. So it is a rectangular sunk key with a head at one end known as gibbet. They are shown the rectangular sunk key, but one end having a gib. So it is usually provided to facilitate the removal of key. So it is used for easy removal of key. So the dimensions are shown. in this figure: width, thickness, and length, and taper. These are the standard empirical relations of a give bed key. The width is equal to d by 4 and thickness is d by 6. So the give bed key is a rectangular type. Only extra in addition to the rectangular key in this give bed key, the head is having the head with a head at one end. That is called as give bed, and dimensions are shown in this figure. So in this diagram, shown this give bed key. This is a keyway, shaft shown. Next, another type of key is feather key. A key attached to one member of a pair and which permits relative axial movement. So this key allows axial movement, relative axial movement. So generally, the keys are used for to control, to arrest the relative motion between the shaft and hub. But it permits relative axial movement. This is a special type of parallel key. It transmits turning movement and as well as axial movement, permits. Another type key is Woodruff key. So the Woodruff keys are semicircle type keys. It is a face from a cylindrical disc having some with radius and shown in this diagram. In shaft also having semicircle type of recess to accommodate the Woodruff key. So it is a adjustable key. Next, saddle keys. Keys are already we have discussed in a previous first slide, two types. One is sunk and another type is saddle key. In this saddle keys, what is the difference between sunk and saddle key? The sunk keys are half of the portion of the key inserted into shaft or hub and shaft or boss of the hub, boss of the shaft, and the second remaining half inserted into a portion. But in this type of saddle keys, not like that. So the completely the portion may be inserted into the shaft or hub. Again, these types, these saddle keys are classified into flat saddle and hollow saddle. The flat saddle type of key is a taper key and fits in a keyway in the hub bed and is a flat on the shaft. So it is usually used for light loads. And hollow saddle key is also there. Hollow type saddle key, it is a taper key which fits in a keyway in the hub and bottom of the key. Is shaped to fit the curved surface of the shaft. So again, next topic is couplings. keys, couplings, joints, all these topics comes under temporary joints. So what do you mean by coupling? So generally the shafts are available in long length, like 7 meters, up to 7 meters the length shafts are available. So main purpose of the shaft is to transmit the power from one place to another place. Suppose you are using the long shafts, it is very inconvenient in transport, and also uh, carrying also very risky, and also bending stress will be induced due to the self weight of the shaft. So that's why it becomes necessary to join two or more pieces of shaft with the help of this coupling. So that arrangement is called as coupling. So main purpose of the coupling is to join the two shaft with the help of bolts and nuts. The arrangement is called as coupling. Again, these shaft couplings are classified into two types. One is rigid type coupling, the second one is flexible coupling. So first one, the rigid type coupling, it is used to connect two shafts which are perfectly aligned. There is no misalignment. Whereas in flexible coupling, used to connect two shafts having some misalignment. So both lateral and angular misalignments. So it means the flexible coupling allows some misalignment. But whereas in rigid coupling does not allow misalignment, perfectly aligned. The rigid couplings are again classified into various types. One is sleeve or muff coupling, and clamp coupling, and third one, flange coupling. So these are the types of rigid coupling. Similarly, the flexible couplings are bushed pin type coupling, second one is universal coupling, and third one is hold on coupling. So classified like this. So main classification is rigid and flexible. Again, rigid couplings are classified into three types, and flexible couplings are classified into three types: bushed pin, universal, and hold-on coupling, respectively. So these are the references I have taken: Bandari, R.S. Kurmi, and R.L. Norton. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.